Example 10 gives us another piecewise defined function, and it's asking again whether the function is continuous or not at the point 2. And notice that 2 again is acting like the border. It's the cutoff of the first graph, the beginning of the second graph. So again, what I have to do is step 1, step 2, step 3. So step 1 is the question, what is g when you plug in the border point, in this case 2? What do you get when you plug in 2 into the function? So again, the problem with these questions is that you have to kind of know which formula to use. Do you use the first one or do you use the second one? And it could be challenging for some people to know which one to use, but don't overthink it. In this case, I am plugging in the number 2. It's exactly equal to 2. So look at the conditions. Which one allows x to be equal to 2? And it will be obvious that the second one is the one that allows x to be equal to 2. So we have to use that equation. So we're going to use the equation 2x plus 1. But keep in mind that we are going to evaluate x with the number 2 in this case, because we are plugging in 2 in the problem. So 2 times 2 plus 1 is going to be 4 plus 1, which is at the end just simply 5. And that's the end, and now we reset everything. So this is the end of step 1, which is great. So now step 2. In step 2, we will find the limit as x approaches 2 on this function g of x. Now again, the number 2 is the border, and we have a different equation on the left, a different equation on the right, so we cannot do this in one shot. So right now this is a question mark, and what we have to do is separate the left limit from the right limit. So I'm going to do the left limit, so 2 minus on this function, which is called g of x, sorry. And we have to do the limit as x approaches 2 from the right on the function g of x. Okay, so again, this one is saying x is approaching 2 minus, so you're slightly less than 2. So which equation do you use when x is smaller than 2? When x is smaller than 2, we use the first equation. So that's the equation that I'm going to use for the first problem. Limit as x approaches 2 minus, and then put 3x minus 5, because that is the equation that represents g of x right now when x is smaller than 2. And again, what you do is plug in the 2 into the x, and you're basically finished. So 6 minus 5 is going to be a 1. So the answer turns out to be a 1. If you already noticed that 5 and 1 are not the same, you can stop right here and say that the function is not continuous. You don't even have to do the second limit. But you know what? Let's pretend like we didn't notice that. Let's pretend like we didn't see it and go ahead and do the next one. So in the next case, it says limit as x approaches 2 plus. So this time my x is 2 plus. 2 plus is a number like 2.1, 2.05, 2.3. They're slightly more than 2. So which condition, the top one or the bottom one, allows the x to be more than 2? It's obvious that it's the second equation. So what does that mean? That means I must use that second equation to find the answer for this problem. So in other terms, for this g of x this time, we have to use the equation 2x plus 1. So let's go ahead and do that. Plug in the limit as x approaches 2 plus first, put the 2x plus 1 next. That's the g in this particular instance. And it's pretty straightforward at this point. Just plug in the 2 into all the x's. So 2 plus 2 is going to be 4. 4 plus 1 is going to be 5 at the end. So this time the limit gives us a 5. So as you probably already noticed, the limits are not equal. One of them is a 1, one of them is a 5. So since the limits are not equal, since the first one was a 1 and the second one was a 5, that means the limit in general will not exist. So if you come from the left and if you come from the right, you do not get the same answer. So that's why the limit as x approaches 2 does not exist. Okay, so now at this point we have to do step number 3. And what does step number 3 say? It says check the first answer against the second answer. So the first answer was 5. The second answer was not even there. We didn't even have a number. It did not exist. There was no solution. So that means what? That means the numbers are not equal. So the g of x function is not continuous at the point that you tested, at the point x equal to 2. And that's pretty much how the problem ends.